So now here, chapter 7, that's the heat transfer. Here we have that first topic, that's the thermal conduction. Basically, in heat transfer, here we are going to discuss about that property of a material. If you just think about a solid material, so in the solid material, that heat will transfer due to that molecules. That point is considered, that is a thermal conduction. As we just think about a solid material, that always heat will transfer through that molecules. As we just discussed about liquid, so that's the heat convection take place. And as we just discussed about radiation, means in a gaseous form. So basically first we focus on that, how that heat will conduct through that any solid material. Here I just show this one simple example. Here on that Bunsen burner, here I just kept that one rod. So due to this heat, that heat will transfer through this rod in this direction. So here we can see that the flow of energy between the adjacent part of a body due to the temperature difference. That's the temperature difference that's important. Between them is called thermal conduction or heat conduction. So as we just think about thermal conduction, that is always take place in solid material. That's it. But that thermal conduction depends on some factors. That whatever they use, that rod, that area of that rod, as well as that length of that rod, as well as the time, कितने टाइम के लिए हमने हीट वहां पे पास किया हुआ है, as well as change in temperature with respect to length, वो भी वहां पे important है. So here as we just think about in detail that thermal conduction, here I can say, suppose if I have one slab, this I just take as a one slab here. That slab I just consider the first point is a A, B, C, D, that first point which is at the distance x, and after some distance delta x, if I have another area that's a E, F, G, H. Now here as we provide heat at the first end at x equal to 0. So here I'll get that the temperature at this A, B, C, D point, that's a T plus delta T. And after some time interval, or after some covering the distance delta x, at this point the temperature is T. It means as we move from x equal to 0 to x equals to L, gradually that temperature decreases. So here we can see that delta Q proportional to minus delta T by delta x, and whenever we just consider that any quantity changes with respect to length, that name is considered a temperature gradient. So here that minus sign, it shows that, this minus sign shows that as we cover distance, temperature value decreases. As well as change in heat, that is also proportional to area, as well as delta small t, means it's a time interval I can say. So delta Q is actually proportional to minus delta T by delta X, A into small delta T. Small delta T, there is a change in a time. Delta, capital T upon delta X, that is considered temperature, how changes with respect to length. Now as I remove this proportionality sign, here I can put one constant, that is a K, where the K that is known as a thermal conductivity constant. So now I can easily write, when I just take this delta T into the denominator, so delta Q by delta T, that is equals to minus Ka delta T by delta X. As I just think about their units, so I can say that delta Q by delta T, that it means how that calorie changes with respect to second. Where I can say area is a 1 meter square. Delta T by delta X, I can say that 1 calorie per centimeter. So now I can say that if area 1 meter square, delta T by delta X is a 1 Kelvin per centimeter. So I can write that's a small k, that's known as a thermal conductivity, which is equivalent to delta Q by delta T. As I use this simple mathematical tool, that's a lambda delta T tends to 0 and delta X also tends to 0. So it means if I use this limit function, I I can make it this delta Q by delta T, this delta Q by delta T as dQ by dt minus Ka. Now I can write this one is a dt by dx. Means how that temperature changes with respect to distance. So, this dQ by dt, and if I make K as a subject, so from the previous part, here we can say that if I make this K as a subject, I can write that K is equal to what? So I can write K is equal to dQ by dt, dx, a dt. As I put units of all the quantity, here the dQ that is given in the calorie, dx it means meter, dt that means a change in time, it's a second, area that's a meter square, and dt means Kelvin. So here 1 meter, meter will cut. So finally I have unit of K, which is known as thermal conductivity constant K, which is equal to calorie per second, meter and Kelvin. Now here it's very very important. Actually ये आपने डायमेंशनल फॉर्मूला फिर से मैंने यहाँ पे दिया हुआ है, ये आपने सेकंड चैप्टर में भी एक इलस्ट्रेशन में ऑलरेडी डिराइव किया हुआ है. As you know it very well, the dimensional formula for a calorie, that's a M1 L2 T minus 2. Second, that's a T1, meter, that is a L1, and Kelvin, that's a K1. As I just combined, so I'll get M1, L1, T minus 3, K minus 1. Is that clear? Now, if I just think about the name of this dQ by dt, that is minus Ka dt by dx, उसका नाम यहाँ पे दिया गया है heat current. The reason is that इससे पहले आपने इलेक्ट्रिसिटी में एक वैल्यू देखा था जिसमें भी dQ by dt आता था, but at that point dQ means charge and dt means time. So change in the charge with respect to time, that is known as electric current. But here this dQ means change in heat with respect to time, so that name we consider as a heat current. So I can write that heat current is equal to minus Ka dt by dx. Is that clear? So now here you can also say that the amount of heat flowing per unit time perpendicularly between the planes having a unit temperature gradient between them per unit area defined to be thermal conductivity. अभी यहाँ पे इस सेमेस्टर में आपको कोई डेफिनेशन वगैरह याद नहीं रखनी है, पर समझने के लिए yes, that's important. So here they just define that thermal conductivity, मतलब K को यहाँ पे वर्ड्स में लिखा गया है. Is that clear?